Hi there, my name is Emmanuel Anam. We are here to talk about the topic agroforestry. Climate change is a global fact. It is changing very fast due to anthropogenic activities on the planet Earth, and by that I mean the effect of human influence on nature. As a result of this climate change, the Earth's temperature is increasing, due to which sea level is also increasing because the glacier at the Antarctic is melting. And trust me, this is very disastrous for the planet Earth. Each time we talk about climate change, it's always the fact that the current situation is worse than the previous, and this affects developing nations more because they get to bear the negative consequences. Measures can be taken to mitigate climate change, but this can only reduce the impact of climate change to a limited extent. Furthermore, agricultural domain is more prone to climate change, and by that I mean that agricultural activities reduce the amount of carbon stored in the soil, primarily because the above ground biomass is removed for decomposition, combustion and harvesting, depletion and erosion of soil carbon. We all know that plants take in carbon just to produce oxygen. That is the cycle. Also, 25% of carbon emission is due to deforestation. Did you know that according to Topo P and A Rash, the concentration of carbon in the atmosphere is almost 339 ppm, and it is estimated to increase till 550 ppm by 2050. Thus, agroforestry is a technique which has the ability to adapt to climate mitigation and adaptation strategies through risk reduction and land use resiliency of agriculture, sequestering carbon, and lowering greenhouse gas emissions. Premeditated growing of trees and crops was a method established in the late 1970s. The importance of agroforestry was enhanced in 1990s for problem solving such as reduced biodiversity, small farm degradation, growing soil erosion, and contamination of ground and surface water. Therefore, agroforestry is now having more importance as a sustainable technique due to social, economic, and ecological factors. However, it is the best ever technique for mitigation of climate change and persistent globally if the proper management is carried out in order to implement the method. It is therefore an excellent environmental friendly method which contributes in CO2 reduction by sequestering carbon to the great extent. Methodology. This is a step-by-step technique taken by our team to bring to life the topic agroforestry. After series of debate and group discussion, by mutual decision, agroforestry contribution to forest land rehabilitation and climate change mitigation has been chosen. Let's talk about the collection of data. Data has been collected from various sources, including survey from people and internet sources for useful data, and useful data has been extracted. Let's talk about the collection of data. Data has been collected from various sources, including internet sources and survey from people, and useful data is extracted from them. Data analysis and research gap. The collected data is analyzed and the results have been formulated in the results section. Gap analysis and research gap has been identified and elaborated in the report. The type of methods, models, and techniques that are used in climate mitigation and their shortcomings has also been identified. Finally, let's talk about the results. The results include what type of trees have positive impact in mitigating climate change and how agroforestry can help to mitigate rising CO2 levels in the atmosphere by, by reducing it above and beneath ground biomass.
Hello everyone, I'm Siddhartha Sapkota and I'm going to discuss about the Eucalyptus caldo calyx, which is also known as the sugar gum. and it is used in agroforestry as a windbreak species, and its use value is for timber, firewood, furniture, and it is a termite resistant species. It is native to South Australia, and in other part of the Australia and in the world, other countries, it is considered as moderately invasive species, and it provides a breeding habitat for endangered species called yellowtail black cockatoos. It was also used as a bioindicator for fluoride pollution in Africa. Looking at the table for carbon sequestration, we have age from 6.7 years to 10.7, so we're going to comparing with other species within this age. So we can see that with increasing age, carbon sequestration rate is increasing, with minimum of 1.57 ton per hectare per year in age 6.7 to maximum 5.64 ton per hectare per year in age 10.7. So basically there might be a question why the age 10 or something like that. So age 10 is because if I'm a farmer, or if I'm investing in agroforestry, I want to get some yield, like commercial or something like that, in short term period. And the concept of the agroforestry and using trees in agroforestry is for short term rotation of the crops and trees. So 10 years is, I think, fair enough long time to wait. So in this another table, I want to show the age, height, and carbon sequestration rate, and also give some insight, like what happened when it's get too old, or some or what is the optimal age for this species for carbon sequestration. So here we can see at age 98, directly at the below of the table, the dry mass and stream volume of these species at age 98 is almost similar, which means the tree is almost dried out, and we can consider it is almost dead, or if you see the carbon sequestration rate, it is really minimal. And the highest is at age 10.7. So we can compare this with the height and age. In different height, 10 sorry, at different age, 10.7, 17.9, and 21.9 years, the height, we have similar height, but the carbon sequestration rate is different. So at the age of 10.7, the carbon sequestration rate is 5.64 ton per hectare per year, whereas it is decreasing with increasing age. And I give it a green green background, so because I'm going with the 10.7 years, if I'm choosing this species, looking at the commercial and environmental benefits from this species. That's it for this species.
So I'll be talking about the second species, Corumbia maculata. Corumbia maculata, also known as Eucalyptus maculata and commonly known as spotted gum, is a species of medium-sized to tall tree that is native to Eastern Australia. It usually occurs in open forest to tall open forest, and it grows between 40 to 60 meter tall and approximately 1.4 meter diameter. The favorable mean annual temperature and rainfall would be 15 to 20 degrees Celsius and 700 to 1800 mm rainfall. It grows best on the moist soil, but it can sustain the dry period as well. The timber of spotted gum is very strong and is exploited commercially for a range of construction uses. It can be used for engineering applications such as bridge construction, railway sleepers, cross arms, and mining timbers. and it is suitable for a range of building applications such as posts and poles, framings, flooring, and lining and decking. So it has the ecological, economical, and apicultural value, and medicinal value as well. The fruits are diuretic, and the bark is astringent that can be used as the medicine. The tree is the major source of winter nectar, and the honey is highly prized, so it has the apicultural value as well. Besides this, the leaves show insecticidal activity and an extract that has been used against the mosquito. So why this species can be used as used in agroforestry, or why it is considered as the potential species in agroforestry? First, it can withstand harsh conditions like dry period for longer period of time, and like being the drought resilient. It is considered to be minimum competitive with pasture. Spotted gum has high tolerance to pests and diseases. It also provides windbreak and block services, which will help to reduce the force of wind and can reduce soil erosion. It can increase the crop yield and protect livestock from heat and cold when planted together with bushes and shrubs. It is considered to be more stable and less susceptible to drying and degrading comparatively to other eucalyptus, and it also provides shades to sheep and cattle. It provides food and shelter to species like koala, and it being the clean, long bark tree, it adds the aesthetic value to the location as well. Now, moving forward, carbon content in Corumbia maculata. Um, as we have been talking about like how carbon sequestration is one of the major benefit of agroforestry for climate mitigation. So in terms of Corumbia maculata, talking about the amount of available biomass and carbon stored in the tree according to its age is represented in this table. The amount of carbon stored in a species is primarily dependent on the height and the age of the species. Carbon content is seen in the greater amount if either of the component is dominating. Carbon is shown on highest amount with age 6.9 years and average height of 10.2 meters, resulting in 7.83 tons biomass and 3.88 tons of carbon. This significant amount of dry biomass makes this species potential species of agroforestry.
I will be talking about the potential third species of this presentation. I have chosen Eucalyptus camaldensis as my species. It is commonly known as river red gum. This species is epidemic to Australia. It grows up to 20 to 45 meters and flowers during summer season. The tree species is smooth with white or cream color bark with adult leaves that are lance-shaped or curved. The flower buds are found in clusters of 7 or 9 and generally bear white flower and hemispherical fruit with bulb that reach beyond the rim. It is found along several watercourses in inland Australia, providing shade into the hotter part of the country, and is also an ecologically and economically significant species in Murray-Darling catchment. Red river gum commonly thrives on riverine side, whether of permanent or seasonal water. It prefers deep moist subsoils with clay content and is most common on grey heavy clay soil along river banks and floodplains subjected to regular or intermittent flooding. Now I'm going to talk about why it is so preferred in agroforestry. Riverine Red River gum was found to be superior in terms of yield and biomass production. It contributes to intense deposition of organic matter on soil through leaves, bark, and root, thus contributing to soil fertility improvement. While considering species for agroforestry, the main property that we seek is straightness, narrow crown, self-pruning, high growth rate, adaptability to wide range of soil and climate, coping capability, and a tendency not to spread as a weed and wide utility of the wood. And this property can be found on eucalyptus species. Red river tree grow under wide range climatic and adapted condition in their natural habitat. It is a fast-growing, easy-to-care, drought-tolerant, and can be grown in poor or less fertile soil. It is a main material for paper pulp production and a major source of bioenergy as well. This species require less water and also aid in water and soil health. Eucalyptus has a lower demand of nutrient than other trees, owing to the fact that the heartwood starts to form at about 4 years. After this, a large proportion of nutrients in the wood are recycled to the other section of the tree or soil, and the amount that is immobilized is kept to the minimum, making it one of the best species for agroforestry. In this slide, I will be talking about biomass and carbon date of red river gum in respect to age and height. The amount of carbon stored by species is highly dependent on two factors, one being the age of the tree and other the height. If one component is dominant, the carbon content will be higher. In the table above, we can clearly see that the carbon content is highest on the trees whose age is 15 years and the height is 15.5 meters. The tree produced 16.54 ton biomass per hectare per year, and it stored 8.20 ton carbon per hectare per year.
The three species we were focusing on were Eucalyptus caladoxyle, Corimba maculata, and Eucalyptus camellodensis. Out of these, we have data sets for around the age of 10 for each tree type. And from this, we can compare these and find out which is the most effective and most efficient in carbon sequestration, from the amount of carbon able to be stored compared to the height of the tree. E. collodalex shows that at the age of 10, with a height of 14.90 meters, it was a carbon weight of about 5.64 tons per year, while also being able to absorb 20.60 tons of CO2 per year. C. maculata shows that aged 10.8 years, with a height of 9 meters, it had a carbon weight of 1.79 tons per year, while also being able to absorb 6.557 tons of CO2 per year. And E. camaldulensis, at the age of 10, with a height of 13.8 meters, has a carbon storage of 1.08 tons per year, while also being able to absorb 3.96 tons of CO2 per year. Now, from this comparison, and with comparing it to the other ages of each tree, we have devised that the most effective tree would be E. caladocalyx. This is due to the tree's relatively high dry biomass and increased height, letting the tree be able to absorb a larger portion of carbon, as much as 5.64 tons per year, with a large intake of CO2 emissions being 20.69 tons per year. This tree also has other benefits such as being termite resistant and it being a native species breeding habitat. As trees and forests have been found to help reduce carbon emissions naturally, they're an effective strategy to help reduce the global CO2 emissions. Even once a tree dies, it takes a large amount of time to decompose, even up to 100 years or more, though if there is a forest fire, the CO2 will be released much more rapidly. This strategy can also be viable in the long term as younger plants are not able to absorb a lot of carbon. But as they grow older, their dry biomass increases, increasing the amount of carbon the tree is able to store. Some downsides to this strategy is if it is fully viable and cost effective in the long term, as the process is labor intensive and takes time to get started, as trees must mature before they can be readily effective to reduce CO2 emissions. Also, there's the matter of land use, as agroforestry takes a significant amount of space to make effective. But we have seen promising results so far, as there are a large amount of benefits other than reducing CO2 emissions. It can also protect soils, improve soil health, and be a sucker to other organisms, leading to also as it being able to be used as farming land. Agroforestry may be one of the best ways we can currently help reduce CO2 emissions that is both a benefit to the climate and agriculture. Though its viability is tested further, research will be needed to confirm the long-term benefits of this strategy in terms of cost and how much does it reduce the atmospheric CO2. But we have already seen results that are promising, which is leading this strategy to be adopted around the world to hopefully reduce and delay the climate change for the globe. Out of the three species selected, the most viable tree in terms of carbon sequestration was found to be the Eucalyptus caldocalyx, due to its high biomass and carbon absorption. This is also a good selection for the environment due to it being a native species, leading it to be resistant to the Australian climate, and already seen as a natural nesting ground for other native species.